In this video, you're going to learn how to install a valid SSL certificate on a CentOS Linux server running the Apache web server. By the way, the SSL certificate you'll install will be issued by Let's Encrypt entirely for free. Traditionally, you've had to pay for SSL certificates and renew them each year, incurring additional costs. Well, with Let's Encrypt, that's all changed. Before you start configuring your Linux server, I want to give you some important background information. This won't be long, just about a minute or so. Now, as a quick reminder, SSL stands for Secure Sockets Layer, and it allows for encrypted communications between a user's web browser and a web server. It's important to use SSL anytime sensitive data is going to be transmitted, such as credit card numbers, personal information, and authentication credentials such as passwords. Even if your web server is not handling sensitive information, using SSL can enhance the trust of visitors to your site. Some web browsers will warn users that the site is not secure unless it's using a valid SSL certificate. Also, search engines such as Google rank SSL-enabled websites higher in search results, so there's an SEO or search engine optimization benefit as well. By the way, this video makes a couple of assumptions. The first one is that your Linux system is running CentOS or Red Hat Enterprise Linux. The second one is that your system is accessible over the public internet. The last assumption is that you have a valid DNS entry that points to your Linux system. For example, if your domain is www.example.com, when someone types in that domain in the web browser, they are actually connecting to your Linux server. I've included some additional information about the DNS configuration that you'll need in the project notes and documentation, so if you need additional help, look there. All throughout this video, I'm going to be using demo.linuxtrainingacademy.com. Now, even though this domain is going to be used in every example, be sure to use your domain when you're following along. The first thing you need to do is to connect to your server. For me, I'm on my Mac desktop, so I'm going to open up the terminal application and simply SSH into my server. If you connect to your server as a non-root user, be sure to go ahead and switch to the root user because a lot of the commands that you'll be executing during this tutorial require root or super user privileges. As you can see here, I'm logged in with the JSON account, and I'm going to switch to the root account by typing in su space dash and hitting enter. Now I'm going to enter the root password. Let's start off by installing the Apache HTTP web server. We'll also need to install the mod_SSL package as it provides SSL support to Apache. So we'll use yum install-y to answer yes to the install questions, and then type in our package names. We'll use httpd and mod_SSL. Now that the web server is installed and the SSL support is installed with it, we're going to go ahead and start the web server. We can do that with systemctl start httpd. You also want to make sure that if your server gets rebooted, that the web server starts on boot. And to do that, you need to run systemctl enable httpd. Now, just to check that the web server started, we can use systemctl status httpd. And sure enough, it says it's active and running, and it lists the processes that are associated with the HTTPD service. By the way, you can also use the is-active option to systemctl. It just gives you very brief output. So we'll do systemctl is-active and then the service name, and it just reports back if it's active or not. And here it is active. Since I'm working on a fresh installation, I really don't have a web application configured or my website on here or anything like that. So I'm going to create an index.html file in the document root of the web server just to put a little bit of data there so I can test with it. I'm going to do that by redirecting the output of the echo command here. That's going to echo demo into the file that lives at var www.html index.html. Now, by the way, that's the document root. If you're unsure what the document root is on your system, you can do something like this, grep-r for recursive, I to ignore case, and then type in document root, and then we'll look in etc HTTPD. And here you can see that the line that is not commented, the one that does not begin with a pound sign, says document root /var/www/html. So indeed, that is the document root that we're using here. If you're using a local Linux firewall, then you need to add firewall rules that allow web traffic, such as HTTP traffic and HTTPS traffic. On this system, I happen to have the firewall enabled, so I'm going to add rules with a firewall-cmd command. So our first rule will be firewall-cmd. We're going to make it permanent. We're going to place it in the public zone. And then we're going to tell it what service that we're going to allow. We're going to allow HTTP traffic. I'll hit enter to add the rule, and then I'll just hit the up arrow key to repeat the command and add an S to the end, because I also want to allow the secure traffic, the SSL traffic that we're going to be using to our website as well, HTTPS. Now that we have the rules added, we can go ahead and reload the firewall. And that makes the firewall read those rules and allow in the traffic. By the way, if you're not using firewall D and you try to execute one of these firewall-cmd commands, it will just simply report back that firewall D is not running. At this point, we're ready to test the web server. We just want to make sure that it's up and running and accepting HTTP and HTTPS traffic. So open up a web browser and type in your domain name. Okay, the page loads. It returns back the information that we put in the index.html file, so it looks like everything is working. The Chrome web browser currently has a warning for any system that is not using HTTPS. So here it gives a warning to the user that your connection to this site is not secure. So let's connect to it over the secure protocol, which is HTTPS. So we'll simply prepend HTTPS : / and hit enter. The web browser displays an error or warning here because the server is actually using a self-signed SSL certificate. Let's actually view the SSL certificate. Here in Chrome, I can go to Settings, More Tools, Developer Tools, and then you need to go to the Security tab. You may have to click these double arrows to see it in the options, but here I have it pulled up recently, so it's already loaded. And then what I'm going to do is just click on View Certificate. It says right away that it is a self-signed root certificate. And if you click on the details, you can obviously see this information is fake. It's made up. It's definitely not a valid SSL certificate. So where did that SSL certificate come from? Well, it came from the mod SSL package. As a matter of fact, when you installed the mod SSL package, it executed a post-installation script that created that SSL certificate. And we can look at this by using the RPM command with the -q for query, and we want to query the scripts for the mod_SSL package. And I'm just going to use a pipe symbol there and pipe the output of that RPM command into the less command, which is a pager that allows us to move up and down through that output so that it doesn't just scroll quickly off of our screen and miss the output. So I'll hit enter here, and it says the post-installation scriptlet using binsh, and it shows you the script that was executed. Ultimately, what this script does is it looks to see if there's a localhost.key file or a localhost.cert file. And if there is, it doesn't do anything. But if there isn't, it goes ahead and generates an SSL self-signed cert. So that's exactly where the SSL cert came from that we looked at in our web browser. Now to get out of the less pager, I'm just going to hit Q. By the way, you don't have to use a full-blown graphical user interface type web browser to check your web server. You can simply do that at the command line with the curl command. So we'll do this. We'll type in curl, HTTP, and then our domain name. Sure enough, what is returned is what is in the index.html file that we created a couple of minutes ago. Now let's check the HTTPS protocol. Curl reports an error. It says the certificate is invalid. And again, we know that's fine because it's a self-signed cert. Here it gives us some instructions to ignore this error if we want to. So we can use curl-k and then provide the address again. By the way, I'm going to use a little shortcut here, which is exclamation mark, $, and hit enter. That exclamation $sign is what Bash calls an event designator. This particular event designator says, give me the last item on the previous command line. So exclamation mark $sign is the last thing on the previous command line. Before it actually executed the command, it showed what it was executing. So it showed the exclamation mark $sign expanded to https demo.linuxtrainingacademy.com. In order to generate an SSL certificate, you're going to need the Certbot application. It's not part of the base Linux distribution, but it is available in the EPEL repository. EPEL, E-P-E-L, stands for Extra Packages for Enterprise Linux, and it's a Fedora project that builds and maintains quality third-party packages for RHEL-based distributions such as CentOS. To add the EPEL repository to your system, simply install the EPEL-release package. So we'll run yum install-y EPEL release and hit enter. Now that you've added the EPEL repository, you can go ahead and install the Certbot application. Yum install-y Certbot. By the way, if you're unsure what package to install or what the package name is, you can search for it with yum. So you could have done yum search Certbot and then looked at your options. If you're still unsure which package is the right one, you can get even more detailed information about a specific package with yum info. And we're going to supply the Certbot package at the end of this yum info command and get more detailed information on it. So there you can see that it gives an extended description, and this can help you decide if that's the proper package that you should install or not. The Certbot application has a few different plugins that allow it to automatically update the configuration for the web server that you're using. Since we're using Apache, we'll install the Apache Certbot plugin. Let's go back up a couple of commands here and do a search for Certbot, and let's see if we can spot the Apache plugin. And sure enough, we can see it there, the Apache plugin for Certbot. So I'm just going to copy this and install it. Yum install-y and then that package name. Now, by the way, if you're using Nginx, you can see there that you could install the Nginx plugin using the package that is listed there as well. Again, we're using Apache, so we'll just install the Apache plugin. Requesting an SSL certificate is really as easy as just executing the Certbot command. If you run the command without any options, you're going to be prompted for all the required information. Because we already know that we're using the Apache web server, we can specify that on the command line with the -- Apache option. So we can use certbot -- Apache, and we also can specify the domain with -d followed by your domain. Here we're using demo.linuxtrainingacademy.com. Now we just simply answer the questions as we're prompted. Here it wants an email address, so we'll just type in your email address. Read the terms of service and then agree with them by typing A and hitting enter. If you want to join the EFF mailing list, you can hit Y here. I'm just going to hit no, I'm already on their email list. The Certbot utility looks through the Apache configuration and tries to figure out where in there you have the configuration for your system. Here it's saying that it didn't find the configuration and it's asking us exactly where to put it. So we're just going to accept the one and only default choice here, which is 1. So we'll hit 1 and hit enter. Okay, again, we get the same question. What configuration file should we use? Again, we'll just hit 1 and press enter. The real choice you have to make here is, do you want to use this easy method or the secure method? Now, if you choose easy here, you can serve both HTTP and HTTPS traffic. If you choose the secure option, then any requests that come to HTTP will be redirected to the HTTPS portion of your website. For me, I'm just going to force all traffic over HTTPS. So I'm going to hit 2 and press enter. Here it gives you some information such as when your certificate will expire and where it's stored at on disk. By the way, if you want to look at all the files that were created by Certbot, you can look in etc let's encrypt live and hit enter here. I'll just use the find command to list all the files in there. And you can see all the files that were generated by Certbot. If you're hosting multiple domains, each domain will have its own directory with its own certificate. Now let's verify the SSL certificate with our web browser. I already have my domain pulled up in my web browser, so I'm just going to reload it. And sure enough, it reports as secure. And if we click on View Certificate, we can see that it's issued by Let's Encrypt, and it says that this certificate is valid. You can also check this at the command line by using the curl command. So we'll type in curl HTTPS followed by our domain name. Sure enough, it returns the information we have in our index.html file, and it doesn't issue a warning or an error like it did when we were using the self-signed certificate. At the time of this recording, the default Apache SSL configuration that is used on CentOS doesn't account for some recent security issues such as Poodle and Heartbleed and those types of things. So to address these security issues, we can update the Apache SSL configuration. Since I'm using a default install, the SSL configuration file lives in etc httpd:/conf.d ssl.conf. Now, if you have a different file that you are using and that you told Certbot about and it put the configuration there, then edit that file. But again, I'm using the default, so I'm going to edit the ssl.conf file. Now I'm looking for the SSL protocol line here. And when we get here, I'm just going to put in a comment. By the way, comments start with a # in this particular file. And I'm just going to say, this is the insecure version. And I'm going to comment out that insecure version. I'm actually going to make a copy of that line and add just one more bit of information here, and that is to disable SSL v3. So we'll go ahead and save that. Now the next thing we need to change here is the SSL cipher suite. Again, I'll just say that this is the insecure default option and comment that out. Now I'm going to copy and paste this big long line of text because I don't want to make any typing mistakes, and that's just the easiest way to do it. So now what I'm going to do here is save my changes and exit. Anytime you're making configuration changes to your web server, you want to run a config test to make sure that you don't have any unexpected typing mistakes or you accidentally use some incorrect syntax. So you can just run Apache CTL config test and hit enter. Now, if it reported some kind of issue or error, go back and edit the file again, fix the issues, and then run the config test again until it says syntax OK. This way, when you attempt to restart the web server to reread that new configuration, you won't end up with your web server being down because of a syntax issue and then have it down while you're troubleshooting. So running the config test first is a very good idea. So now that the config test passed, we can make the Apache web server restart, which makes it read all that new configuration that we supplied. I'm just going to execute the curl command against our website and to make sure it's up. Sure enough, the web server is up, it's returning our web page, and everything looks good. SSL certificates issued by Let's Encrypt are valid for 90 days. To attempt an SSL certificate renewal, use the Certbot application. So we'll run Certbot, renew, and hit enter. Here it reports that our certificate is not yet ready for renewal. The Certbot renew command will renew all previously obtained certs that expire in less than 30 days. If it does do a certificate renewal, it will also restart Apache for you. Here it didn't even attempt to do the certificate renewal, so it's okay to run this command as many times as you want because it won't even try unless it's ready to be renewed. Now there are a couple of different ways to handle SSL certificate renewals. One way is a more manual way. You could, for instance, put a note in your calendar to remind yourself to log into your system and run this command to renew your cert. But if you're like me and you have a busy day and you overlook a calendar event, then you may run into a situation where you have an SSL certificate expire and your visitors will be getting warnings and errors about an invalid certificate on your site, and that's no fun. So there are a couple of ways to automate this process. One way is to create a cron job. To create a cron job, we can run the cron tab -e command, and that is to edit our cron tab. Now I'm just going to put a comment here about what this job is going to do. Renew SSL certs daily. The first 5 fields of a cron tab entry are actually a time specification, and they represent the minute, hour, day of the month of the year, and day of the week. So I'm just going to have this command execute every night at midnight, and how you can do that is you type in 0 for 0 minutes, 0 for 0 hours, and then use asterisk for the remaining time specification fields. The command that we're going to put here will only be executed when all the time specification fields match the current date and time. When you use an asterisk, it matches any date or time for that field. So here we've only specified the hours and minutes. So every night at 0 hours and 0 minutes, this job will get executed. So what we want to do is supply the command that we want to be executed at midnight. So we'll use user bin certbot, and we're going to do renew. Now this will generate some output, and if you don't do anything else and just save your changes here, when this command executes, it will produce that output, and it will send an email to the account associated with this cron job, which is a root account on this system. Now that may or may not be what you want. Personally, I don't want an email like that. What I want to do is just save a log file on the system. And so how we can do that is just redirect all the output generated by this command. This ampersand followed by the greater than sign says redirect all standard input and standard output, more or less everything that this certbot command could generate, and put it into a file. And so what we're going to do is put it into var log certbot.cron log. Now every time this command gets executed, it overwrites that file. But for me and my purposes, that's good enough, because if the SSL cert, something wrong has happened, I'll get notified via our monitoring system, or potentially a user of the website will notice something, and then I can go back and look at this log file to see what happened with the renewal process. So once you're done adding your cron job, you can save your changes. And to check that it's installed, you can use cron tab-L to list your cron jobs. There's a second way to automatically schedule the certificate renewals. That method uses systemd timers. The Certbot package includes a certbot-renew systemd service. When you start the service, it attempts to renew the SSL certs on the system just if you had typed certbot renew at the command line. This particular service is not like most services because it just simply executes that command and immediately exits. It's not a background service where it constantly runs, for example. So let's just execute this service and see what happens. Systemctl start certbot-renew.service and hit enter. Now let's check its status. Systemctl status certbot-renew.service. Here you can see that it's actually inactive, and at the bottom of your screen you can see the output that is exactly like you would have expected had you had run the certbot renew command from the command line. So again, this service just executes that command and exits. Luckily for us, the Certbot package also includes a systemd timer that will execute the certbot-renew service daily. The first thing you want to do is actually start the timer, so we can do that with systemctl start certbot-renew.timer. We want this timer to start on boot, so to enable that happening, we can use systemctl enable certbot-renew.timer and hit enter. Now you can view the status of all the systemd timers using systemctl list-timers. Here you can see that there are two timers that are listed, the certbot renew timer and another one. So this tells us that in 11 hours from now, the certbot renew timer will be executed. Now there's information that scrolls to the right of the screen, so I'm going to hit the right arrow. And when I do that, it kind of readjusts our view to the top of the screen. It's using a pager to do this. So it says, let me move over to the left. The unit, the certbot renew timer, scroll to the right here, says that it activates the certbot renew service. So this timer will start the certbot renew service, run the certbot renew command, and exit. So I'll hit Q to exit out of this pager. So that is the alternative method to scheduling the daily renewal. By the way, if you're going to use that method, then I highly suggest that you disable the cron job, and we can do that with cron tab-E. Go ahead and comment out the cron job line there, write and quit, save your changes, make sure that the cron tab saved, and you're good to go. So again, you only have to use one method, the cron tab method or the systemd timer method. Just one will do. Let's quickly recap what we've covered. In this tutorial, you learned how to install an SSL certificate issued by Let's Encrypt on a CentOS system running the Apache web server. You started out by installing the Apache web server and mod SSL for SSL support. From there, you added firewall rules to allow HTTP and HTTPS traffic. Next, you enabled the EPEL repository by installing the EPEL-release package. That enabled you to install the Certbot application as well as the Apache Certbot plugin. You then created and installed an SSL certificate using the Certbot utility. Finally, you automated the certificate renewal process so that your site is never without a valid SSL certificate. If you enjoyed this tutorial, then I know you're going to love all the other videos, tutorials, and courses available for you at linuxtrainingacademy.com, and I hope to see you there.